I'm Ashok here from Wari Energies. As you know, Wari Energies is one of the old players in the solar industry. We've been in the industry since 2007, one of the largest manufacturers of solar panels in India, and a leading EPC company. So now in this forum, we've been discussing about technologies which are for the future, where we can bring in more adaptability into the rooftop market and unlock new segments. So I would like to present on a technology which we at Wari believe is going to bring a huge potential into the solar market, and we believe in it and we believe in the technology. So I shall get on with the presentation right away. So I'll give you a quick brief about Wari Energies. So we are present across the entire solar spectrum right now. We are a module manufacturer. We are an IPP with over 150 megawatt project portfolio. We are also an EPC company with more than 300 megawatts of utility projects. We've done about 7 megawatts of rooftop projects, and also we are into solar products. We are into water pumps. So we are present across the spectrum. And recently we've launched our own solar inverters for the small 1 to 15 kilowatt range as well. So this is our portfolio. We are also a Tier 1 module manufacturer now. So one of the very few companies in India to be rated Tier 1 by Bloomberg. So this is a factory in Surat where we have a 500 megawatt capacity, which is being upgraded to 750 megawatt by this year, and our target was 2 gigawatts by 2019-20. At the moment, we are making poly and monocrystalline modules. That is our core competency, and the innovation we are bringing in is to upgrade this poly and monocrystalline modules to give a better performance as well as a longer life in terms of rooftop applications. Yeah. So this is our project snapshot. As you say, we've done a couple of 1 megawatt projects rooftops, and the largest project which we are doing currently is a 2 megawatt rooftop project in Maharashtra. And also in utility, we've done a 75 megawatt project in Surat. We have 50 megawatt in MP and a 44 megawatt with single axis tracker, which is under installation in Telangana. These are some of the key projects which we've done. Yeah. So now I'll come to the topic where we feel there's a need for innovation in the current crystalline module offerings, which is available in the market. So as you can see, the traditional modules, which is a 3 bus bar or a 4 bus bar modules, have a aluminum frame which is required for the reinforcement, which makes them a bit bulky and difficult to handle. And then they also need to be earthed when we're using in rooftop to avoid any shocks, etc. Plus, they're also very susceptible to micro cracks if we engage them into, if it is exposed into vibrations due to, say, wind load or any other factors. All of this needs heavy mounting structures to mount them on the roof. And then with regards to cell interconnection, we have a 4 bus bar or 3 bus bar interconnections, which can have residual stress during the whole process, and also which can also lead to impact the life in long term. And also because of this current layout, the current capacity, current collection is not very efficient. As you can see in the presentation, we've shown how a 4 bus bar module is collecting current, which we believe can be improved to improve the cell to module efficiency. And also it limits the form factor. We have square modules, and that's about it, which are rigid and which are pretty bulky in size. So, and it limits the like if you compare to thin film, we don't have a AC mounting option, etc. So we are trying to address these concerns through a new technology, which is called Merlin. So when we were considering an innovative technology, these were our key considerations. So we need to improve the cell module performance, reduce the losses, and also by doing all this, we didn't want to disrupt the existing production line, because there is a huge production capacity which is built up in terms of cells, etc. So we wanted to use the current polycrystalline and monocrystalline technology cells, and then upgrade them using a slightly better technology when it comes to module manufacturing. And that's how we've arrived at Merlin technology. Merlin is actually a technology company based in US. We have an agreement with them to exclusively market the product in India. So the modules will be manufactured by Warwick with a licensed technology firm, Merlin, based in USA. Yeah. So this is the module lineup we are talking about. Using this Merlin technology, we can use existing polycrystalline, monocrystalline cells and make them into flexible modules, foldable modules, and even roll-up modules. So, which was earlier not possible because the cells could be easily damaged and micro cracks and other damages which reduce the life of the product. Now, with this Merlin modules, they are very capable of taking a lot of stress. They don't damage that easy. And also, even if micro cracks are formed, it does not really affect the performance of the modules. That is the advantage we bring with Merlin technology. So some of the features of the modules. It's a cell technology agnostic, so we can use the current cell technology, which is poly or mono, or even mono, PERC, etc., for making these modules. It can be integrated into the existing production lines because there is no change in the existing manufacturing style. It's just at the screen printing stage where we bring about a slight change in how the module, the printing is done, the silver patterns. Now, using this technology, we found out that we can improve the power output by up to 3.5% on the existing cell by simply using this mesh technology, which is introduced by Merlin. And also a 50% reduction in silver consumption. Now, silver is one of the components which is adding to the cost of cell manufacturing. Now, using the mesh pattern, which is developed by Merlin, we can bring down the silver consumption by up to 50%, which in turn leads to a cost saving. Now, in solar, every penny we can save is passed on to the customer, which leads to a lower tariff. And also, these modules can be made frameless, so you don't need a bulky aluminum frame, you don't need earthing, and you can easily mount them using a back rail or clamps. So that makes your BOS cost also come down to some extent because you don't need an extensive module mounting system. You can have a simple aluminum rail to mount these modules. We are also exploring a peel and stick module, which has been already being employed in US. But in Indian conditions, where the high operating temperature we are just exploring the feasibility of such a peel and stick application as well. Now the module is much lighter, and also we have flexible modules which can be developed for portable applications and military applications. So now, I'm not sure if you can see the picture very clearly. This is how the Merlin technology is been applied to a cell. As you can see, this is a mesh which will be collecting the current, and instead of the traditional bus bars, we have a tab which is interconnecting the cells. So instead of 4 or 3 connections between a cell, we have 180 plus connections between each cell. Now that gives a lot of room for stress handling to avoid any damages, which in turn helps us remove the frames and make the modules more flexible and lighter. And also the mesh acts as a reinforcement. So basically what it does is it encases the wafer, which is quite brittle, and provides a reinforcement and additional strengthening to ensure that it does not really get damaged when undergoing some sort of stress. So we've tested this in the laboratory. The results are excellent compared to the traditional 3 busbar or 4 busbar modules. The power output is better, and also the module can handle a lot more environmental stresses, which are typically a factor when it comes to rooftop modules. So this are some of the lab test results which you can see here. So here we can see this is a test which was done to under extreme vibration and bending. So you can see here the traditional modules crack very easily, whereas the Merlin modules are very minimal damage. So the power output is not really affected. So even during transportation, installation, or even after installation, if there is any sort of stress which is coming on the modules. We can these modules are much more tolerant to it. So that is one of the advantages. And as you can see, the power loss is minimized, whereas the traditional modules lost nearly 30%. The Merlin is hardly losing about 0.5% of the power due to damages. And also another advantage is the finger width has been reduced. We can achieve up to 30 micrometers in the cell printing. So with that, there is less shading due to the silver fingers, and as a result, the power output has been increased by around 3%. We're getting better output. So what are the advantages of Merlin modules? So as you can see, these are some of the applications which are already installed abroad. We also have a few projects which are coming up in India. We have installed a 20 megawatt capacity at the moment for Merlin modules, which we hope we will be expanding to about 500 megawatts in the coming few years, depending on the demand. And as you can see, these are much lighter weight modules, and they can be straight away laid onto the roof, especially based on the curvature or the profile of the roof. So traditionally we have to go for a flat or a slant roof. Now there is more opportunity for round or any other shapes or profiles for the roof. Now a peel and stick application is also being explored. I can show it in the next slide, where it has been already applied to car parking, etc. And we believe there is better module life, and also performance. If you've been to our stall in RAI, we had demonstrated that by parking a bike on top of the modules and without any damages for more than 3 days. And also it was laid out on the floor for people to walk on. Even there was a dance performance which was held on top of it. And these modules were able to take a lot of beating. So overall it's a much better module without really changing the base technology. Yeah. Applications. Now apart from the traditional rooftop market, we see a lot more potential in vehicles. Now we have e-rickshaws in Delhi. Now we have trains which are exploring the potential of modules to be mounted on top of it. Now, and BIPV is another application. Now these are aesthetically better looking modules also. So we can integrate them to for buildings. We can have a back rail which allows for vertical mounting, and so a wide, there's no limit to which we can imagine how these modules can be used. Because the foldable modules can be used for portable applications. Earlier, we had seen a lot of development of portable solar generators. Now, they've kind of died down because the batteries were heavy and the modules were huge. So now, when we have foldable modules and lithium ion or the new battery technologies, we see a lot more portable applications coming up, be it in the case of telecom towers or any other application, portable solar, we can bring it back with these sort of modules. And yeah, so this is an example of peel and stick modules which are actually installed using Merlin technology. This was actually done in the USA by our partner company. As you can see here, they simply peel there's an industrial glue which is applied to the back of the modules, and they can be applied directly to the roof. However, in the Indian conditions, we are still evaluating how it will work, because the temperature buildup is going to be quite significant. The normal operating temperature is quite high in India. So probably a little trade-off between module peak output, but you're saving the BOS cost significantly, should still lead to a lower LCOE, is what we are expecting. Yeah. So that was a quick presentation. I hope you have enjoyed it. If you need more information on Merlin, please visit our website, or you can contact us, because we are always here, and our office is in Bikaji Kama in Delhi, and our head office is in Bombay. Thank you.